this lecture actually will do a quick proof of the Pythagoras theorem. So which says that if you have a right angle triangle like this, so if it is A, B, and C, this is 90 degrees, we have A square plus B square equals C square. Let's take a look at the proof. So let's say this is that triangle. So this distance from here to here is A, from here to here is B, and then this is C over here, right? Now, once we draw the triangle, we extend this length by the distance B, and then we take a vertical line, and first after the triangle we draw a square with sides C, and then this length is B. So therefore, when we draw this line at 90 degrees, this will have the length of A, because we have a right angle triangle which has three sides A, B, and C. So then when we complete the square, you can see very easily if this is B, this is C, like this, and we are extending it by A, so that this big square has A plus B, A up to here, then this will be B, then this will be A, this will be B, this length, and this will be A. So what you can easily see is the area of the big square is A plus B square, and that is equal to the area of the inside square plus 4 times the area of these triangles, which we know is half of A times B, so which is 2AB. So we get A plus B squared equals C squared plus 2AB. So if we expand it, we get A squared plus B squared plus 2AB equals C squared plus 2AB. We can clearly see, we can cancel this, and we get A squared plus B squared equals C squared. And then from that point on, we saw in the last video how we can derive this one, from which we can derive these two. Okay, so that finishes this part of the lecture. And now let's look at law of sines, law of cosines. Now, law of sines says if you have a triangle, now this triangle is not necessarily a 90-degree triangle. It has angles A, angle B, and angle C. These are the 3 angles, and the sides opposite to these angles, uppercase A, B, and C, are lowercase a opposite to A, B, and then C. So let's prove sine A over A is sine C over C. And similarly, then we can show that one of these is equal to this, and we would have the law of sines. So now, from this point, you draw a vertical line down like this. So at 90 degrees, 90 degrees, 90 degrees. Okay, so let's call this height H. Okay, now what we have is H is equal to C sine of A. C sine of A. So if you have a right angle triangle, you know the angle and you know the hypotenuse. The vertical height is C sine A. The horizontal, this projection, is C cosine B. Why? Because sine A is height or opposite over the hypotenuse. H over C is sine A. Therefore, H is C sine A. But this is also equal to, if you look at this side, A sine C. A sine C. Now compare these two, and you can see that sine A over A, so just take over A, is equal to sine C over C. And that's this side is equal to this side. All right, okay? So this was obtained by drawing a vertical line from B, and we were able to relate sine, A terms and C terms. Similarly, if you take a vertical, line from C onto there, then we can relate A and B, and we'll be able to prove that this term is equal to this term. So this is the law of sines. Okay, now let's look at another very important result, which is true again for any triangle. Doesn't have to be right angle triangle. So once again, we have a triangle with angles being A, B, the whole angle, and C angle. All right, and let's prove this, and these three are just symmetric proofs. So here we have angle C, and the side is, so this should be uppercase A, B, and uppercase C, and these are lowercase a, lowercase b, and lowercase c. Now if we draw a vertical line here, okay, and say this length is h, so it's at 90 degrees, then h is equal to lowercase a sine of c. And this whole length is b, so this length here, okay, let's call it lowercase d, d is equal to a cosine c. So then what is this length? This length will be b minus a cosine of c, right? This whole b minus this d. Now we can apply the Pythagoras theorem to this triangle, which is that c square, this c square, is equal to h square plus b minus a cosine c square. What is h? H is a square sine square c, plus this, which is plus b square plus a square cosine square c minus 2ab cosine c. Now combine this term and this term. It becomes a square sine square c plus cosine square c, and that is equal to 1. So therefore the right hand side becomes a square plus b square minus 2ab cosine c, because adding these two together, you can take a square out, and it becomes sine square c plus cosine square c, which is 1, so it becomes a square. So this is the proof of the law of cosines. So now we have seen proofs of the law of sine and law of cosine. Now in the next video lecture, which will be the last one on pre-calculus, we will look at the addition formula, sine x plus y, and from there we'll be able to derive the rest and also derive these double angle formulas, okay, and half angle formulas. So all of the rest, they come from the first equation, whose derivation we will see, and the rest will just be a consequence of the first equation.